that we see we can categorize. And that's what we're going to work on today. Putting a number into as many categories as it fits. So the very first thing that you're going to ask yourself on every single problem is my number rational or is my number irrational? Every single number is going to fall into one of those two categories. We actually already talked about rational numbers. There's three different things that make a number rational. It could be a fraction. It could be a terminating decimal. It could be a repeating decimal. So when you look at a number, the first thing you're going to say, is it rational or is it irrational? And you're like, well, is it a fraction or a terminating decimal or a repeating decimal? If you say like, oh yeah, it is, then it's going to fall into the rational category. Irrational means it is a long, never ending decimal with no pattern. It's not a repeating decimal. It is a number that goes on in all crazy order. There's no pattern. There's no rhyme or reason to it. Can you think of the most common irrational number in math, Spencer? It is pi. Pi is the most common irrational number. 3.1415, blah, 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 blah. Nobody really cares after 14, right? Let's just talk about 3.14. Okay. The other common irrational number is a square root that is not a perfect square. A square root that is not a perfect square. This is where I want you to grab your calculator. Those of you that I stopped and looked at your calculator, there's a setting on there I wanted to change before you type something in, otherwise it gives you a weird answer. Type in the square root of 8. (2.828427.125). You got a decimal, no pattern to it. Okay, nope. Hit Shift Enter. That's the button. Oh, sorry, second. Oh, yours is 1 too. I didn't realize that you had the same calculator. I apologize. Now type that in again. Square root of 8. Do you think that decimal ends at the end of your computer screen? No. It carries on and on and on forever. Did it work now? Yes. It carries on and on forever. And there's not a pattern to it. Because the square root of 8 is not a perfect square. Remember, our perfect squares were the numbers that we dealt with on your 1-9 worksheet. 1, 4, 9, 16, 25. Because when you take the square root of them, you get a whole number. The square root of 49 is 7, because 7 times 7 gives me 49. If you tell me a number is irrational, you don't have to label it in any other format. That's the only category it fits into. But if you have a number that's rational, it may be able to be labeled lower. The next category that a number could fall into is integers. Anybody remember what an integer is? Yes, sir.
A whole number.
There's a little bit more to it. Aspen, add to it for him.
Positive, negative whole number?
Bingo. Positive or negative whole number. And this is weird because everybody says, yeah, it's a positive or negative whole number, but what is a whole number? Aiden? Perfect. That's exactly what I was looking for. So it's a positive or negative number that doesn't have a decimal. It's just that whole number. So rational numbers are fractions, terminating decimals, or repeating decimals, but then sometimes we can even say that they're integers. And then the next group is called whole numbers. What do you think the difference is between an integer and a whole number? Very good. Whole numbers are only the positive numbers without, wow, that's a weird looking W. I always say W/O without a decimal. And the most specific category that a number could belong to is called natural numbers. And natural numbers are your counting numbers. They are what you teach a little kid to count. It's ultimately the same as whole numbers, but it doesn't include zero. When you teach a little brother or sister or a niece or nephew or a cousin to count, you don't say, okay, now we're going to count. Ready? 0, 1. You don't count 0 with them. The first number you teach a kid is a 1. So natural numbers are your counting numbers. Ultimately, the only difference between these is whole numbers, but not including 0. Okay, so what's the point of this? I want us to be able to know what category numbers fall into. So what I like to do is I like to think of this chart as talking about Brandon Valley kids. Okay? All of you guys belong to the Brandon Valley School District, right? So that's like the rational number category. And all of you attend Brandon Valley Middle School, which is like your integer category. And all of you are in the 8th grade, which is like the whole numbers. And all of you have Miss Hoff for math, which is the natural numbers. So every single one of you is in Miss Hoff's math class, an 8th grader, go to Brandon Valley Middle School, Brandon Valley student. What if I went next door, pulled somebody out of Mrs. Hoosier's room? Are they rational?
Yes.
Do they belong to the Brandon Valley School District?
Yes.
Yeah. Are they an integer?
Yes.
They go to the middle school? Yep. Are they a whole number? They're an 8th grader? Yep. Are they a natural number?
No.
Why not?
Because it's not Miss Hoff.
They don't have me. So they still are a rational, an integer, and a whole number, but as soon as you say no, you quit. What if I go across the hallway to Mrs. Ring? Pick a random kid out of her room. Are they rational?
Yes.
They go to Brandon. Are they an integer?
Yes.
They go to the middle school. Are they a whole number?
Yes. No.
What was whole numbers?
8th
8th grade. Ring teaches only 7th grade. What if I drive into Sioux Falls? I pull some random kid and say, hey, where do you go to school? They say T. What category do they fit into?
Irrational.
Irrational. They don't belong to the Brandon Valley School District. I don't care anything else about them. They're irrational. I should have made a better choice, right? Yeah. Okay. So you want to put numbers as far as you can into the categories. All right. Strip at the bottom. Let's practice this. First number I'm going to give you, 3 divided by 2. 3 divided by 2. The very first question you ask yourself is, rational or irrational? Why? Perfect. Rational because it's a fraction. So because we said it's rational, we got to check the next one. The next one says integer. Is that an integer? Why not? Okay, when you take 3 divided by 2, what do you get? 1.5. That's not a whole number because Aiden gave us a really good definition is you can't have a decimal. So the only category it fits into, rational. -7 pi. You already know that, Ray? Irrational? You guys agree with him? Yeah. As soon as anything involves pi, done. Irrational. No reason even to consider it anymore. And we cannot categorize anything further than irrational. How about 12 divided by 6? Rational? Irrational. Why is it rational? It's written as a fraction. Very good. Because we said it's rational, we got to check the next category, which is an integer.
Yes.
But it's a fraction.
But if you divide it,
But-
it's 6.
Bingo. It's not 6. I was like, yes! Oh, that's not right. If you divide it, if you can simplify, you absolutely should. So really, what number should we be talking about? A 2 here. Okay, so now let me rephrase it. Is it an integer?
Yes.
Yes. A positive or negative whole number. So because we said yes, we check the next category. Whole number. Yes. And the last category check, natural number. Yes, it is.
I was in natural.
Natural, basically the only difference between whole number and natural number is 0. When a little kid counts, do they count to 2?
No. Yes. Not from 0 though.
Not from 0, but do they get to 2?
Yeah.
Like when you teach a little kid to count? Absolutely. Calix, question.
So for a natural number, it shouldn't be negative, right?
Correct. Even a whole number can't be negative. All of your negative numbers are going to stop at integers. Does that make sense? Good question. Okay, so taking what we just learned is if you can simplify it, you probably should. I want you to do this one all on your own. Ready? Negative square root of 100. Negative square root of 100. On your own, list every category that that number belongs to. Very first thing you're going to want to do is simplify if you can. Negative square root of 100. Can you simplify that? What is it? Careful. Negative 10, right? Okay. Rational, irrational. Rational. Integer?
Yeah.
Yep. Whoa, no, don't stop working. Integer. Whole number? Why not?
Negative.
Very good. It's negative. Calix just asked me this question. It was a really good question. As soon as a number is when a number is negative, you stop at integer. It's never going to get further than that. Okay? Say what?
Good job.
Good question. On the back side of this is blank. I'm going to go over a couple things from your homework. If you want to take any notes on there, you can. Okay? I can still show you Alex because my account is still good. So I'm going to show you. What I did is I just took the online account or online assignment and I made a worksheet for it. There's just a couple I want to talk about. Yeah, I actually have an answer key and I'll sit over here and you just bring it to me. It's actually a great question while I'm pulling this up. I'm going to let you have the worksheet and you can answer one, you can answer the front page, you can do the whole thing and then bring it over and check it. I'll start if it's right and I'll circle if it's wrong. Yep.
We get 3 tries.
You get as many try. I don't have another copy of this, so it's probably better than doing it on Alex. You're just gonna do the same one. But I bet it's not gonna take you even 3 tries on the problems.
If you have a computer, you still can.
No, it's not even to do with your computer. It's to do with the program. We don't have a license for you. When you log in, it'll say your class is inactive.
Yeah, I tried to see if there's an assignment.
So, all right. First problem asks, is there an integer or not? What's an integer first off?
Positive or negative?
Positive or negative whole number, okay? 27 divided by 9. Integer, yes or no?
Yeah.
But it's a fraction. 27 divided by 9 is 3, so this would be yes. 54?
Yes.
Negative 7/3?
No.
No. 65?
Yes.
Negative 80.9?
No.
No. Now let's check your intelligence here. Well done. Okay, this one, people are like, oh, I don't know how to do it. It's really not that hard. Okay? So I'm going to give you different decimals, and they want to know if it can be written as a fraction, and they want to know why. To be honest, the reason, answer first, will tell you this. So the reason says this is a terminating decimal, which means it ends. This is a repeating decimal. There's a number or numbers that repeat. Or this is a decimal that neither terminates nor repeats. Now, on 1-1, you guys took terminating decimals and repeating decimals and rewrote them as fractions. So if you say it's terminating or repeating, that's going to tell you yes.
Yep.
If you say it's neither one, then you're going to say no. Okay? 0.87, terminating, repeating, or neither? Terminating. Can it be a fraction? Yes. 0.7 with the bar above it. Terminating, repeating, or neither? Repeating. Can it be written as a fraction? Repeating, yes. Yep. 0.111, this dot means it goes on and on and on. Terminating, repeating, or neither?
Neither.
Repeating.
It's repeating.
Yeah.
They didn't put it in correct notation, but it's repeating, yes?
Well, what if it's different numbers?
Just wait. Can this be a fraction, yes or no? Repeating, yes. Last one, 0.257963. This means it goes on forever. Terminating, repeating, or neither?
Neither.
In that case, it's neither. So up here, when they start the pattern, you know it's going to continue that. Where here, there's no pattern to it. So that's how you know it's neither terminating or repeating. Can it be written as a fraction? No. So terminating and repeating is always yes. Neither one is no. Let's double check we did this correctly, and we're good. All right, this last one. Whoops, not that one, number 4. Venn diagram. Okay, remember how Venn diagrams work is everything in this blue circle actually also belongs to the red circle and also belongs to the green square. So what they want us to do is use these 3 labels to label the 3 sections. And then we need to put the number into the lowest category that we can get it to. So, integers, whole numbers, rational numbers. Which one's the green one? Rational. The biggest, tallest category is rational. Then rational numbers could become integers and then whole numbers. Okay. We want to place these numbers in the most specific category we can. Negative 29. Is that rational? Is it an integer? Positive or negative whole number? Is it a whole number? No. Who wants to tell me where negative 22 goes? Integers? It can't be a whole number? Do you guys agree with him, integer? Okay. Who can tell me where negative 3/2 goes?
Oh, no.
Aiden? Just rational? That's it? Integers?
No, because it can't be rational.
What is 3 divided by 2? 1.5. So you don't want to go any further? You were totally right. 5.79. Nothing lower?
Yeah.
Why not?
Because it's
Not a
a
whole
decimal.
number.
Very good. 0.
Nothing.
Integer.
Integer.
Integer. Because the whole number can't be 0.
Are you sure?
Yeah.
Are you sure?
I'm positive.
Jack's standing strong with whole number.
Can't be 0. Wait, it is.
No,
Look,
but
no,
that's
that's
natural.
It's whole.
But not 0. No, that's natural.
Oh, it is whole number. It is whole numbers.
Do a fist pump. Jack, you win. Yay. Okay, your guys' diagram goes to natural. Natural isn't on this. 0 is a whole number. Now let's hope this is right. Oh, thank the Lord. Okay, so on your worksheet, you have the same type of diagram. Don't get lazy. Actually write them out. I don't care if you do one problem, if you do the front page, if you do the whole thing. I'm going to be sitting at that back desk. Bring it to me. I'll start if it's right. I'll circle it if it's wrong. And we just keep cycling through that. Now, here's the only thing. This is not a group assignment, right? You still should be doing this on your own. Can you use your notes? Absolutely. But you shouldn't be asking each other. Cool?
Yeah.
This is due on Tuesday when you come to class. All right, let's rock and roll. No.